Welcome to another episode on my Arduino Yun, spelled Y-U with an accent N. Originally an Internet of Things board, but I disabled the Internet of Things. So it's just a board right now, running Linux, as well as being a normal Arduino, including some fischertechnik motor, another motor with propeller, and a lens lamp with a power controller, which is right here. Also probes for the oscilloscope, which is right here, and quite a lot of electronics. Now, if you've seen my previous episodes, then you know what things are. To be sure, pot meters to control the speed of these motors, and some RC circuits, one here and one here. Two buttons to have the propeller stop and go again if the speed is low enough, and NTC thermistors, one here and one here. So topics or focus is actually that last time it showed that for a lamp to heat up the NTC thermistor proved to be, well, not really satisfying. First of all, the voltage of this lamp is way too high to function for the Arduino to control, or to be controlled by the Arduino. 9 volts is needed and it can't, and the Arduino has maximum 5 volts. Hence the power controller, this one. On the other hand, there's another NTC with an LED which is more or less directly connected to the 5 volts, but it doesn't burn. So why is that? Apart from that, also another LED here, which is controlled by this wire, but why doesn't it burn? Well, if I take a look at the oscilloscope and look at the dark blue line which is at the bottom, that may be a very good reason. It is a bit wiggling, but not showing a voltage that it should work. So that may be a setting in the software, which I have to check. So let's run some stuff, and first of all, of course, in order to run this propeller, I have to have some input from the SSH terminal. Let's do that first. First log in, then give input by giving enter, and then it would be very nice if the motor actually started to work. So with a little manual aid it does. Then with a screwdriver I turn up everything, and then it is supposed that this motor will stop working. But so far I do not see that happen. to my surprise. So why is that? It used to do that. It doesn't do a thing. So let me test this potmeter, which is for that motor. See, they're both influenced again. And despite me turning the screwdriver, this one doesn't really stop. Now I turn this one on again. LED burns, and there you go. Is this as expected? Not quite. But first things first, I want this LED to work. So let's just take a look at the code. At pin 10. Why it doesn't work?
So it is about this LED for now. Input from output 10. Where is 10? This one. So amongst all the code I have written so far, including through time quite a few errors and mistakes, but still, where is 10? And I have to look for, of course, analog out pin 10. Six and 11. Again 6 and 11, then 13. 13, 13, 11. 3. Yeah, that's in. A3. Analog out pin 10. Right. So if either value smaller than 50 then out pin 10 is 0, otherwise it's 256. Otherwise smaller than 0, but is it? No, it's way larger. NTC value is right now like that. So it will never happen. Or, no, it will happen. NTC value larger than 50. What is the sensor value? Sensor value 2 is 843. Well, so I have to go here, then with 843 larger than 500, NTC value is 8 something, which is here. So why doesn't it work? Because it clearly doesn't work. So for delay 1, well, I don't care about delays at the moment, I just want it to work, and if this means that it doesn't work at all, let's forget about the delay then for now, and let's, well, I think 265 should be visible. So if I turn back the light, no, there's nothing visible. So I can safely assume that this perhaps will not happen. But then again, why doesn't this work? So let's make this 512 and see now what happens. Oh yeah, right, my mistake. I should say Yun, and I should say this one. So once again, uploading. Always check for the right thing. Now it is going right. We should be. Alright, that's done. So doing this again, and then see what happens. So with this change, do I actually see this LED work? Not really. As a matter of fact, the oscilloscope doesn't give anything either. Which leads to the question, is it actually pulse width modulation? So actually yes, it is. It is the Yun is concerning the pins comparable with the Arduino Leonardo, and that one has these pins. So why isn't this one working the way it is? That is a very genuine question. Without power or without any signal, there's nothing. Oh wait, it's measuring slope now. This is pulse width modulation. So let me put the oscilloscope to pulse and see whatever happens. So I change this to pulse. And then again, source. Alright, let's put this to channel 4 now. But still, even with this, there's nothing. Absolutely nothing. This is no good. No good at all. So channel back to 1, and this back to slope as I wanted. Although it is pulse width modulation, but there's nothing there. Absolutely nothing. Which is not good. That said, is the wire okay? That is a very genuine question as well. So, what if I test this output, and then let me grab this. What if I test the output right here and see if there is anything coming out of it to here, because if there's a wire problem, then I won't get anything here. And I'm measuring right now here at the LED. So that's another point. Let me do that. So taking this probe away and relaying it oops, be careful. Right. And yet again, oh wait, it's closed. And without doing anything, there's no signal. Now there should be at least something. Giving it output. Once again putting it to pulse. Channel 4. Oops, this is not correct. This should be pulse. Channel 4. Nothing. Okay, I should investigate on pin 10. That much is clear. So let's do that. And the devil is once again in the details. When I look here at the information which has to do with the Arduino Yun, which is, as I said, compatible in pins with the Arduino Yun, which I am using, I read pulse width modulation. Well, several pins, including 10, but then it says provide 8 bits PWM output with the analog write function. 98 bits. So 8 bits, talking binary, 2 to the power 8 is maximum 512. Am I correct? 10 bits is this. No, then I'm even not correct. 10 bits, 2 to the power 10 is 1024. 2 to the power 9 is then 512. 2 to the power 8 is then 256. So, going here, this is never going to work. Maximum is then 256. Then this is never going to work either. So my original idea was quarter, half, top. Well, then this, if this is the top, then this is 256. Half is then not even 128. And then this is a quarter, is then 64. Is it even watchable? That's a very good question. So let's see if this is going to work somehow. I'm very curious. So, only way to do is test. and then see if here something happens. Go for it. What does it say? Permission denied. What is this? Is this an error or is this... I have no idea. Go. What is wrong with console? Let's quit this. Go. Port. Ah, wait. This happened before. This happened before. Why it happens, I have no idea. Alright, do again. This is a lot better. Why does it change port? Very odd. Alright. Now I have to check, giving some input. Maybe it even already works. Alright, some input. And oh yes, it works. Look. And not only that, this is clearly a good result. So, will it change when I do this? Well, let's see.
So, this one works now, but does it also get influenced by the setting of the pot meter? Oh yes, this is one thing. Turning it up. And this is working as well. At maximum stand, maximum setting, the fan stops. This one. And you get this. Now let's take a look at the oscilloscope. Right here, you see there a very nice pulse width, and you see here the signal from the second pot meter. So now I will turn the pot meter, and you will see the signal change on the oscilloscope. Turning it up. And that is what this is about. So how will this respond? Well, right now the LED is off. So now the question is, looking at the actual circuit, can I make a distinction with this LED in frequency? Because it should be visible with which frequency it works. Oh, and then of course I have to give input. Without input nothing happens. So there we go again. Maximum. I do not see a difference. Also not with the naked eye. And whatever change of frequency there is. Downside is of course that it is only 8 bits. And there's a whole range difference in 8 bits and 10 bits, being, as said, difference between 265 and 1023 as maximum, or to 1024 values, because the range starts at 0. So it's actually not 265, it's 260. Yeah, it's 255, not 256. So actually the lowest value is 255, where it that's interesting. It does work, that's clear. Is it maximum? That remains to be seen then. Anyway, this works. One remaining issue is now, apart from, yeah, that still works, and that should flash, but doesn't. Alright. Then this one. Why doesn't this LED burn? Is it because of it's broken, or something else? Because as you can see, it is connected to power, 5 volts. Well, via resistor, but anyway, that's next. Last part for this episode. As you can see, I've taken it out of the board and connected to the power controller, which I used to power the lens lamp right here. And you can see that the LED is working nicely. And since this side is the minus, I have to put it exactly like this into the circuit. So let's do just that. And which one is which? Yep. So this should be working. It clearly is not. So the question is, why is it not? Probably because of this resistor. So I may consider putting this resistor away, but I may also see putting a probe right there. So let me remove this probe, put it here, which does absolutely nothing. So let me show, it's a purple line right here, which does nothing. So let me change the setting to slope, and which says absolutely nothing. Is there any power right here? There's no power. Am I measuring the right one? Yes. This is quite interesting. It shows that there is absolutely no power. Because now it actually should measure power, and it doesn't. Alright, this is interesting. And everything is connected. So, looking here at this red wire transferring power from here to here, then from here to here. So every bit of power that is here gets transferred here and should be here as well, but I don't get power over this line, which is quite interesting. So that's another thing to check on, which I will do next time. So, thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, and feed forward, push forward, or whatever you do with social media. Please follow me on Twitter, retweet and like, follow me on Instagram and like, give thumbs up. Please donate to keep videos coming to you. More information at the start of this video and on my website, which is listed at the start of this video and under this video. And this is going to be continued. Bye bye.